Cool. So ETH 2.0 and EIP1559. ETH 2.0 is sort of a in-progress update. EIP1559 is a upcoming update to Ethereum. I guess before starting, just go through. I think Simon asked me to put in a quick difference between Ethereum and Bitcoin explainer at the start. So I'll speed through it, and if there's any questions, just feel free to ask. So Ethereum was Bitcoin. So we start with a Bitcoin transaction. So a Bitcoin transaction basically consists of a set of inputs and a set of outputs. So over here we've got total of 8 Bitcoin coming in, total of 8 coming out. Everything's good. In a Bitcoin block, we have a proof of work. We have a link to the previous block, and we have a set of transactions. And then we can form a chain of these blocks. And we go back to the transactions. So we've got the set of inputs. There's something called UTXOs, so unspent transaction outputs. So all the inputs on one side consume transaction outputs and give us a new set of transaction outputs. So going back to here, we can see on the first block, we've got a state with one transaction output. Block 2 perhaps has a transaction which takes that one transaction output, gives us 2. Block 3 has another transaction. Block 4 is another transaction. I guess the point here to note in relation to Ethereum is the transaction outputs themselves aren't, or the state of transaction outputs aren't directly stored in the block. It's just something that you can look at the ledger of transactions and figure out which outputs haven't been spent yet and kind of calculate that separately. An Ethereum transaction instead has a state rather than transaction outputs. So the state, instead of just being a set of values or a set of an amount of Bitcoin or amount of Ethereum, can be anything. So we take a state in, and we get an output of another state. So that the transaction can do a lot more things. So if we look at the blockchain here, we've got a set of transactions inside the blocks, and then state is just a set of key value pairs. So in this example, we've got A1, B2, C3, and then state 2. Perhaps we've got a transaction that sets B to 5. So now we've got A1, B5, C3, and so on. So we can generalize that a lot more. And then the state itself is actually broken up into sort of components, I guess. So each component is kind of you've got an address. Each address has a balance, and then the address can either have a nonce if it's a wallet. So a nonce is just something that you use to keep track of how many transactions the address is made, and you've got a contract storage if it's a contract. So you could in the example that ERC20. Sorry, I know the slides are a bit small, but you'll have to bear with me. In this example, we've got an ERC20 token. The state that's stored is the balance of each account. We've got the total supply, and then we've got a name and a symbol for the ERC20. Now I guess we can go into ETH 2.0. So why ETH 2.0? So scaling, that's a graph of the total gas limit in Ethereum. So in Ethereum, computation consumes gas. A small transaction might only take a little amount of gas. A large transaction will take a lot of it. So this is a historical gas limit going back to 2015. And as you can see, we've steadily been increasing it as demand grows. But even though we've been increasing it, the utilization, as you can see, is pretty much pegged to 100%. So scaling by simply increasing the gas limit just isn't working. We need a lot more scale. And along with that comes the fees issue. So because blocks are constantly full, fees get pumped up pretty high. At one point earlier this year, the average transaction fee hit almost $70. So you can imagine, if you were doing a large transaction at that time, you'd be spending multiple hundreds of dollars to put that transaction through. So ETH 2.0, we've got a set of design goals that we need to meet. So we want to deliver on-chain scalability. So we don't want to. There's a popular method of scaling ETH contracts where you do all the computation off-chain, and then at a certain set interval, maybe once a day, once a week, you publish the changes or a summary of the changes on-chain. The problem with this is you do have issues where in between the time of doing the computation off-chain, so whoever's running the off-chain network, or layer 2, as it's called, can refuse to publish it on-chain, or there's the potential for various different attacks. So off-chain scaling is not ideal. We want to keep everything on-chain. And also we want to put in proof-of-stake consensus. So proof-of-stake consensus lets us do a much larger volume of transactions. And there's also environmental benefits to proof-of-stake as well. What we currently have, and we don't want to give up, so we want to maintain decentralization. So keep barriers to participation as low as possible. Availability, it's no good if we have massive amount of scalability, but a week from now the entire network's deleted and no one can use it anymore. Security, so obviously we don't want people to fake transactions, perhaps create an infinite amount of ETH out of nothing, which is not great. Usability, that's probably a bit arguable how usable Ethereum is now, but we don't want to sacrifice usability. And value, so Ether is currently pretty foundational to using Ethereum right now, and we want to maintain the value of Ether. Secondary goals, so some nice to haves. WebAssembly, so eWASM, allows us to use more robust programming languages. At the moment, the programming languages for Ethereum are somewhat esoteric and very easy to create bugs in. That's mostly because I haven't really been around for that time, and there's some other limitations around it. But WebAssembly would allow us to use much more established programming languages where behaviors are more understood, and it's a lot easier to write bug-free code. Synchronous and atomic cross-shard transactions. I guess I can come back to that one later. Stateless execution, I can probably come back to that one later. And could have storage rent, just a quick explainer of that. So right now, if you put something in storage on Ethereum, if we go back to the slide where we kind of had the state of Ethereum, we stick something into that state. It's very expensive for nodes to keep something there because you need to make sure, or things that are in state need to be always available to calculate the next block. But if someone goes and sticks something in the state, that's there forever. So a could have is storage rent. Maybe we can retire things out of state to make it easier to run a node. So the ETH 2.0 kind of upgrade roadmap. At the moment, we've got our Ethereum main chain. It's our anchor layer. It's how we are running things right now. And everything happens on the one chain. There's no, consensus. All the transactions, all the smart contracts, all happen on there. So right at the beginning of the year, we had the ETH 2.0 phase 1, or phase 0, sorry, deployment. So what you could do there was basically, if you had 32 ETH, you could take your ETH, you could send it over to this beacon chain. And the beacon chain is sort of the first sort of component of ETH 2.0. The only thing that it does is it validates itself. There's no transactions that occur on it, and there's no smart contracts. It's more or less just a pilot. Make sure everything's working all right. We don't have any issues with the proof of stake consensus layer before we start moving any sort of use case onto it. So that's the beacon chain. This was scheduled to be midway through the year. It's been delayed. But shard chains. So shard chains are where we start to actually have things other than just plain consensus. So we've got a data layer. This is where we store state. And great. There's a little bit of a delay between that. And we have VMs. So this is where our WebAssembly or our EVM, as we have it now, will run, and they make changes to the data layer. So the VMs would run smart contracts or just regular, sending ETH around transactions. And the final step, we remove the main chain. And the main chain basically just becomes another shard chain. So rather than bring proof of work, remove the proof of work, and everything is now proof of stake. So as part of those changes, we've got pretty wide-ranging adjustments that need to be made to the existing ETH1 blockchain. So we got consensus algorithms. Right now, we're proof of work. So you basically just burn a bunch of compute cycles. There's absolutely no benefit to the compute cycles being burnt besides coming to consensus on the chain. Block times tend to vary a little bit because proof of work is probabilistic. You might have a block that's 10 seconds. You might have one that's 25. The target block time is around 13 seconds, but some applications might rely on timing being accurate. So having this variation in block times is not ideal, and you can't really get time resolution, or you can't get time more accurate than about 30 seconds in a smart contract. So if you have a use case that needs time more accurate than 30 seconds, you can't build on Ethereum right now. With proof of stake, that is possible. Right now, we've got probabilistic finality. So once something's mined in a block, there's because block times on Ethereum are so short, you constantly have blockchain forks, and they'll eventually resolve themselves over a couple of blocks, but you don't get instant guarantee that your transaction is final. And as more blocks are mined on top of the block, you get more and more certain, but you can never be truly certain that your transactions got through. Whereas with proof of stake or with ETH 2.0, you get true finality, and of course there's the environmental concern with proof of work. Proof of stake doesn't take anywhere near as much electricity to run. Concurrency. Right now, the entire ETH1 chain is effectively single-threaded. So we've had computers that have multiple cores, run things in multi-threaded. We run multiple threads to gain more performance of the computers. This has been true for a a long time, but the world computer, Ethereum, is still single-threaded, so that's not great. ETH 2.0 makes it effectively multi-threaded, so we can process transactions in parallel. That gives us better or faster transaction verification, or it's easier to run a node with more transactions. So if we can, we've got runs at speed OC and then OC squared. So basically what that means is if ETH 1.0 right now, we have a single blockchain that can process, say, 1,000 transactions per second, and we have shards of that chain, which you can peg to the main chain with only one transaction per block, then the total number of shards that you can run is 1,000, and then each of those shards being identical to the main chain can also run 1,000. So instead of only being able to run 1,000 transactions per second, you can now run 1,000 squared transactions per second. So we get exponential scalability out of it. And at launch, where the plan is to launch, or the plan was to launch 1,024 shards. That might have been reduced to 32 shards more recently. There's still discussion around finalizing some of the numbers here. Hello? There we go. Yeah, so we've got the Ethereum virtual machine, which is sort of what I explained earlier. We've got esoteric programming languages. AWASM or WebAssembly lets us use more traditional programming languages. We have better smart contracts. They execute faster, and we can reason about their security better. And with ETH 2.0, WebAssembly is not the only virtual machine that we could use to run smart contracts. It's fairly modular, so if we have a different smart contract VM somewhere later down the line, that can also be switched out. There we go. So crypto economics. There's a fair amount of changes here to make proof of stake work. So right now, if you mine a block, you get the block reward for mining the block, and you also get the transaction fees paid by all of the transactions included in that block. So that's just a purely reward mechanism. In ETH 2.0, with the move to proof of stake, we have more of a carrot and stick approach. So if you participate honestly, you run a node, you don't try and perhaps steal funds or try and put through a malicious transaction or anything, you still get the participation rewards. So you still get the coins for mining the block. But the difference is we now have slashing. So if it's proven that you acted maliciously, so in order to, sorry, I kind of got a little bit ahead of myself. So in order to run an ETH 2.0 node, you need to have 32 ETH. That gets locked up. If you act maliciously, part of that 32 ETH gets slashed, so you lose a little bit of it. And the longer you, or the more actions you take that are malicious, the greater the penalty. So if you only take one action, maybe we can say that's a mistake or a software bug, or perhaps your power went out at home and your node went offline. So you only get penalized a little bit of it, a little bit. But you can bring your node back online and then earn back the penalty fairly quickly. But if you show a pattern of consistently malicious behavior, you have what's called a quadratic leak. So the penalty increases as you continue to do malicious behavior until eventually you're losing your entire stake very, very quickly. And then you've got the false proofs, which are basically you've got you can prove malicious behavior or prove that a node might have been offline or detrimental, that a person's been taking detrimental actions against network, which enables the slashing and quadratic leak. And then there's the cryptographic primitives stuff. So of course, it's a cryptocurrency. Clearly, people want to build cryptographic protocols on top of the currency or on top of your smart contracts. So right now we've had a very limited set of tools or cryptographic tools for smart contract developers to use. So you've got, Ketchak, there should be SHA as well on there, as your hash functions. You've only got one signature type and one curve that you could use, which is great until someone comes along and wants to do a fairly novel use case that doesn't or isn't possible with just the cryptography that you've got there. And they have to go on and implement their own cryptography within the smart contract, which has the issue of being potentially prone to errors, because number one rule of cryptography, you don't write your own cryptography and just deploy it. You make sure it's peer reviewed and all before you deploy it. That's very difficult to do when deploying a smart contract. So ETH 2.0 gives a much wider tool set. Most of these are actually geared towards zero knowledge proof systems. If there's time after the presentation, I can get into what zero knowledge proofs are as well. But there's a number of different cryptographic primitives that enable that. And networking. So right now, the entire network, the way nodes communicate with each other, runs on something called dev P2P. You don't get multiplexing. So what multiplexing allows you to do is kind of, in parallel, make different requests to different nodes. So it is a fairly limited protocol that nodes talk to each other with. And this kind of leads to a situation where wallets, rather than directly communicating with the ETH network, most of the time you'll see they'll actually, the wallet developer will actually run a node with some API service that the wallet talks to. So it's not ideal, because if the wallet developer decides that they no longer want to maintain these API services, or they want to know certain information about your transaction, then there's a possibility of censorship there and would force you to change wallets. So there's a possibility that a wallet that works now will no longer work in the future because the wallet developer's gone and disappeared. This is a fairly unique problem to ETH. Bitcoin-like chains have had wallets that have been able to directly communicate with Bitcoin, with the Bitcoin network for a while, or even through a protocol like Electrum. So the move here in networking is to libp2p, which you've got independent shards which allow multiplexing. So shards, again, with a separate execution, or the separate chains back in the previous slide. And you can allow light clients and stateless clients. So basically, your wallets, or perhaps very constrained devices. Perhaps you want to run an IoT device that talks to Ethereum directly. You can run that on libp2p. So we actually get a much wider range of applications that can talk directly to the ETH network and be a lot more resistant to potential censorship, or if the wallet developer disappears, the wallet still ends up working. And come on, there we go. And with nodes, so with ETH1, there's a fairly limited set of node developers. Problem with that is if someone wants to push a change through the network, the less nodes there are, the easier it is for a small group of people to unilaterally make a change to Ethereum. With ETH 2.0, because a lot of the architecture is easier to implement, or it's easier to actually build a node for, we've got a lot more node developers. So there's 10 different implementations, 9 different organizations. So the Ethereum Foundation runs or maintains 2 different nodes. The rest of them are all by separate developers. And there are 7 different programming languages. So in terms of off-chain applications, there's more developers that are able to create applications for Ethereum, which is always good. I guess that's a rundown on ETH 2.0. Coming to EIP1559. There's a lot less to talk about with EIP1559. It's sometimes considered part of ETH 2.0, but it is a separate upgrade. Basically, the fee structure in Ethereum right now, the entire transaction fee that you pay goes to the miner, and there's a couple of interactions which are problematic with that. So if you pay the entire fee to the miner, you're now effectively in a bidding war with everyone else using the network. And some of those users are, perhaps arbitrage bots or something like this, where potentially there'll be an arbitrage opportunity between 2 exchanges on Ethereum, and let's say there's $100 worth of profit there. The arbitrage bots will, bid against each other. So one might say, okay, I'll pay a $50 fee to get the $100 of value. The next one might say, I'll pay 75, and so on. So this drives the cost of or the transaction fees up. Because regular users now have to compete against these arbitrage bots. EIP1559 changes the fee structure, so now you have a base fee which doesn't go to the miner, that just gets burnt. And you've got a optional tip which does go to the miner. But the idea is this MEV bidding, or miner acceptable value, where the arbitrage example before is an example of MEV. The bidding war doesn't affect the base fee, so you've got a layer of insulation, to regular users, so they don't get as affected by these arbitrage bots and potential other bidding users. And the last thing is it does make ETH potentially deflationary. So right now, the only thing that happens with Ethereum is when you mine it, more gets created. There's no mechanism to take Ethereum out of supply. With EIP1559, because you're burning the transaction fees, that's actually now a mechanism to take Ethereum out of supply. All right, and that's EIP1559. And that sort of wraps things up. Simon, how are we going on time? We good?
Perfect.
Sweet. Questions?
We've got time for questions. We've had some questions already which I circulated, and people had already put in if we are stuck, but maybe we'll start with ones in the room, and if you've got a question online, just tap it into the notes and we'll read it out.
I have a question.
Yep.
Tell me about Railgun.
Railgun. That's a project that I'm currently involved in, bringing privacy to Ethereum. So interact with DeFi privately.
When is that going to be implemented?
Railgun or ETH 2.0?
No,
ETH 2.0. ETH 2. Okay. I deliberately left dates off the slides because this timeline keeps changing. There's a there's a meme, you've got Vitalik as kind of the more or less a public face of ETH, or the most public figure in Ethereum. And there's this common meme where it's, like, shown Vitalik as an old man, and it says, oh, ETH 2.0 finally released. So phase 1 has released, or phase 0 has released. Phase 1 was scheduled for sometime now, it's midway through this year. It's been postponed to the end of the year. And then phase 2 has been postponed to next year. Yep.
Do you know why it's been delayed?
So I had the slides with the 10 different node implementations. One of the downsides, or one of the upsides of having a less node implementations is you can actually push through changes more easily. So, yeah, it's a trade-off. So getting everyone to kind of agree on the exact implementation details on some of this stuff and actually push out software which is compatible with it is a incredibly difficult task. Yep.
Is learning Solidity still a good idea?
So I had WebAssembly up there. WebAssembly is also one of the things that has been consistently delayed for a very long time. So for at least a foreseeable future, Solidity seems to be the way forward.
If you weren't going to go with Solidity, what would you go with next?
I just want to repeat the questions. We'll speak really loudly because the online people don't hear it
Oh.
particularly well.
Sorry, okay, I'll repeat it because for the online people, because I've got the mic. So if I wasn't going to code Solidity, what would my next preference be? For smart contracts, most non-Ethereum chains have settled on Rust. It's a systems programming language, very well understood behavior, and it makes it a lot easier to make or to write safe code. Yep.
So MEV seems like would be a pretty big problem. I mean, something similar happened on Wall Street 10 years ago. Why does current stance to kind of minimize it and not fully get rid of it?
So from a blockchain level or protocol level, it is almost impossible to eliminate MEV. It is possible to minimize it. So the idea is on the protocol level, you would minimize it as much as possible. And then you would kind of hope that smart contract developers kind of follow best practices around actually eliminating the MEV in the smart contracts themselves.
I'm just going to take an online question just to share them around. One of the questions is, how easy will it be to mine ETH2 versus mining now? Number of days.
Okay, how easy will it be to mine ETH2? So with ETH2, you need 32 Ethereum. When ETH2 phase 1 was launched, that was about 3,200. Right now, you'll have to look up the current price. But
72,000.
Yeah, about 72,000. Okay, so it is very expensive to get an ETH2 node. But once you do have an ETH2 node, rather than kind of having rewards per block and having to use a pool in order to get more consistent mining rewards, ETH2 itself will give you fairly consistent mining rewards as long as you're not engaging in behaviors detrimental to the network.
So is that to say that rather than winning blocks, you'll just get a consistent stream?
Um,
Fairly consistent stream?
yeah, you will get a fairly consistent stream. Yeah.
Okay, sorry, back here.
Assuming that you can actually set up a node, money node, in your example with arbitrage bots, can you front run them and generate profit from?
Yeah. So,
Repeat the question.
okay, if you have a mining node, is it easy to set up arbitrage bots?
Yeah, in front run pretty much.
Yeah, in front run.
Trying to
So with ETH1, if you run a mining pool, you essentially get unilateral decision-making power on what transactions are included in that block and the order of those transactions. So in ETH1, front-running by mining pools and miners is fairly easy to do, and you're essentially relying on miner goodwill, which some of the major miners have kind of honored that. But there's examples of miners engaging in front running and arbitrage or MEV extraction. With ETH2, for each shard, there's a committee of mining nodes. So you no longer get the unilateral decision-making power. It's kind of because of the committee, you've kind of got to go through and actually convince everyone else that you want to actually insert your transaction in before. So it is still possible to an extent, but that has been, very, very minimized from what we have it now, or will be.
Going to go to a question that was asked, and is quite topical these days. It was asked as part of the registration process. What are the environmental implications of this change, and how long will such improvements take to kick in?
Okay, I'm going to quickly flip back to my ETH. There we go. So we've got main chain layer. We've got proof of work. Come on. Proof of work, stage 1, and then stage 2. So I keep calling phase 1, phase 0, phase 1. Let me start again. So phase 0 gave us a beacon chain. Phase 1 will give us shard chains. And then phase 2 takes away the main chain. So whenever phase 2 is implemented, we actually start to see the environmental benefits. Up until that point, Ethereum mining is still going to be, or proof of work mining is still going to be a thing. Phase 2 is currently scheduled for 2022 right now.
Anyone else in the room, on the chat?
I'll go back to questions that were asked. What are the chances of a hard fork going wrong or not being accepted by the community?
What are the chances of a hard fork going wrong and not accepted by the community? In terms of acceptance, that's the reason why things are delayed. All of the different development teams and the interests of the various different organizations, getting everyone onto the same chain is pretty difficult. The benefit, though, is we get a lot more analysis that goes on, a lot more time for analysis for a lot of these hard forks. So there's not a significantly larger risk of something going wrong in ETH2 as opposed to a hard fork in ETH1. And ETH1 hard forks happen multiple times a year. The simplest hard fork that we do is just increasing the gas limit. There's various other tweaks that go in to making blocks more efficient to verify.
Okay, I'm going to keep going with the questions.
All right.
Thought about when they had a bit of time. This is a two-part one. Is proof of stake as secure as proof of work? And what are the risks with proof of stake?
Okay, is proof of stake as secure as proof of work? And what are the risks of proof of stake? It's a measure of trade-offs. So there is an issue with proof of stake networks earlier on, where the supply might be fairly centralized. So there's only a couple of factors that need to collaborate or in order to potentially push through detrimental effects. With ETH 2.0, there is, so we've got fault proofs, which sort of makes it a little bit more difficult to actually push through detrimental effects, because there's proofs of bad behavior which you lose your stake for. I would say for Ethereum's specific case, proof of stake is actually more secure, just simply because there are a number of different attack vectors given by the fact that blocks right now are kind of decided on unilaterally by the mining pool that mine them. For other chains, the trade-offs might be different. So for other chains, it might actually be more secure to run on proof of work rather than proof of stake. It's just it's a matter of trade-offs.
There's another question here about comparing it with Cardano. So almost led into there, but we don't have to have a sledge match.
Yeah. Well, as Cardano and ETH stand right now, Cardano's they're not competing on the same thing. Cardano doesn't have smart contracts, and ETH does. So they are separate chains. Perhaps when Cardano gets smart contracts, it'll be a different comparison.
How will dApps improve after the adoption of ETH 2.0?
Okay, how will dApps improve after the adoption of ETH 2.0? So one of the biggest issues with dApps right now, the biggest issue with dApps right now is transaction fees. For the vast majority of use cases, transactions are just prohibitively expensive. So if you're paying $100 per transaction, you'd better be making more than $100 of profit on that transaction. Otherwise, it just makes no sense. So the biggest kind of improvement to dApps is the fact that transaction fees are lower, significantly lower, in ETH 2.0. So the number of use cases that can be applied are greater. The secondary benefit to ETH 2.0 is the fact that the node networking stack changes. So right now, your dApp front end, if it goes offline, or if the team running the dApp front end disappears, there's the way that the majority of dApp front ends work. Essentially, they rely on an API or a backend service provided by the dApp development team. There are ways to kind of avoid that, but most dApp developers don't bother. So if the dApp developer disappears and takes the infrastructure offline, your dApp front end no longer works. So you got to wait for someone else to come along and deploy another one using their own infrastructure or a different set of infrastructure, which is not great. You get your coins locked up in a protocol. The dApp developer disappears. How am I getting my coins out now? So with ETH 2.0, it makes it a lot easier to build dApps or dApp front ends that don't actually don't rely on the developer continuing to stick around. That's the other improvement.